Elon Musk has a brand new master plan, and this one is all about how Tesla is going to save the world. Which sounds dramatic, maybe even a bit far-fetched, but here's the deal. Tesla's mission statement has always been to accelerate the world's transition to sustainable energy. That's the setup. So Master Plan Part 3 is all about the follow-through. What exactly would it take to fully transition a global economy to sustainable energy? What does that cost? How do we accomplish it all within the next 1 or 2 decades? Let's get into it. The key message behind this new master plan is that the Earth can transition to a sustainable energy future, and it can happen within our lifetime, and it's not going to be anywhere near as costly or damaging to the environment as most people have been led to believe. Elon and Tesla have laid out a clear path to a sustainable energy Earth that doesn't require the destruction of nature, doesn't require austerity, and can actually provide abundance. A sustainable energy Earth can support a much larger civilization than the one we have today. One of the key reasons for this is that our current fossil fuel-based energy system is highly inefficient. 80% of the energy we use comes from fossil fuel, and only 30% of the fossil fuel energy that we extract from the ground is actually converted into usable working energy. The first rule of thermodynamics is that energy can neither be created or destroyed, only altered in form. The reason that we extract fossil fuels like crude oil is because they are very dense with stored energy. We want to convert that energy into a form that does work for us. Typically, we are trying to convert fossil fuel energy into kinetic energy. The internal combustion engine is a mechanism to convert energy from liquid fuel into kinetic energy, the energy of an object in motion. That engine has one job, but it actually doesn't do it very well. Over 2/3 of that energy stored in the gas tank is not converted into motion, it's converted into heat. All of the heat that radiates out on a combustion engine, all of the heat that flows out the exhaust pipe, that is wasted potential energy. It did nothing to contribute to putting the vehicle into motion. Then think of all the wasted heat energy that was created to extract that oil from the ground, refine it into fuel, and transport that fuel around the country. Electrical energy offers a significantly higher level of efficiency. It's still not perfect. We know that electrical devices do still create waste heat. You can feel that from something like a laptop that's been working too hard. But if a combustion engine is down around 20 to 30% efficiency, an electric vehicle is typically sitting around 80% efficiency. So, what does all that mean? The takeaway here should be that an electrified economy will require significantly less total energy to operate than a fossil fuel economy, and this is due to efficiency. If you waste less, then you consume less. So when we compare sustainable energy to fossil fuel energy, we have to remember that we are not comparing apples to apples. Here's how the equation changes. Right now, we require 165 petawatt hours of energy per year to power the global civilization of Earth. Only 1/3 of that energy is converted to useful work or heat. So with just higher efficiency alone, a sustainable energy economy would require only about half of that energy, 82 petawatt hours per year. A petawatt hour is 1 trillion kilowatt hours. Your typical electric vehicle can hold around 70 kilowatt hours of energy in a battery pack. So we're still talking a very large scale number here. Anyway, the point that Elon really wants to drive home here is that there will be no substantial increase in demand for resource extraction or ecological impact in a sustainable energy future. There will actually be less. Right now, we are extracting about 68 gigatons of minerals from the ground every year. Under a sustainable energy economy, that would reduce to around 54 gigatons. This is, again, really important to remember because most people just assume that an electrified world will require more mining. But that's not true. There will actually be less mining in the future, and eventually, there will be none. Companies like Redwood Material have already achieved 95% efficiency in recycling lithium-ion batteries. We can take a fully spent battery pack from an EV, convert most of that material back into refined ore, and then make a whole new battery pack. So here's what a sustainable energy economy looks like. 240 terawatt hours of global energy storage. That means stationary storage products like the Tesla Megapack and Powerwall, in addition to the energy stored in EV battery packs. This is a lot of batteries, vastly more than we have the capacity to produce right now. So this is a big change that needs to happen, and it needs to come soon, but it is an achievable amount. That needs to be supported by 30 terawatts of renewable power generation, which will come primarily from solar panels and wind turbines, but also includes geothermal, hydroelectric, and nuclear. We know that Elon vastly prefers solar to wind energy because the sun is a giant nuclear fusion reactor in the sky. It provides far more energy to the Earth than we could possibly utilize at our current level of civilization. And the amount of physical land required to support that energy generation works out to around 0.2% of the solid land mass of the Earth. And the great thing about wind turbines is that they don't even need to be installed on solid land. We can put their foundation in the water. We can even put solar panels in the water as well. So that's all great, but what is this going to cost? Tesla puts the number at $10 trillion for all of the manufacturing and resource extraction associated with building this renewable global energy system. That's about 10% of the global GDP for 1 year, which is around $100 trillion. So if we spread this plan out over a decade, that's 1% of global GDP spent per year. That's really not that bad. The master plan identifies 5 key areas of work that need to be accomplished in order to bring our fossil fuel use down to zero. The largest and most important area is obviously renewable power generation and storage. If we convert all of our grid electricity to renewable sources, we eliminate 35% of all fossil fuel use. Specifically, we need 24 terawatt hours of dedicated battery storage. That means grid-scale products like the Tesla Megapack. Right now, the company can manufacture about 40 gigawatt hours of Megapack storage per year. There are 1,000 gigawatts in a terawatt, so that needs to increase drastically. This needs to be supported by 10 terawatts of solar and wind power generation. In 2022, 60% of the new energy generation that was added to the existing grid was solar power, and solar installations are growing 50% year over year. So we can accomplish this. The total cost to repower the existing grid with renewables is going to equal out to around $0.8 trillion of manufacturing investment. The second key area is transitioning fully to electric vehicles. This will reduce fossil fuel consumption by 21% globally. This one is pretty self-explanatory. We're all familiar with electric cars. There are a couple of important factors to consider. One is that this will be very expensive, $7 trillion of manufacturing investment to fully eliminate the internal combustion engine. The price to payoff ratio is not so good, but consideration number 2 is autonomy. The more vehicles that are fully autonomous, the fewer total vehicles will be required because each vehicle will offer greater value. An autonomous vehicle doesn't just sit around in a parking lot doing nothing. It contributes more work over time. The third key area is heat pumps. By switching all homes, businesses, and industry to heat pumps, we can reduce fossil fuel use by 22%. And that comes at a cost of just $0.3 trillion. So a very similar total impact to electric vehicles at a tiny fraction of the investment cost. And heat pumps are ideal because they do not create heat. They only transfer heat. We don't have time for a full rundown, but a heat pump is just an air conditioner in reverse. It moves heat from the outside to the inside. Even if the air is very cold outside, your heat pump can make it hot by the time it reaches the inside. Tesla has already introduced heat pumps into every vehicle that they sell, and Elon yet again put it out there that Tesla may introduce a heat pump for your house someday in the future. The fourth pillar is electrifying high-temperature industrial processes. So just think about all of the energy we use to melt raw materials so that we can turn them into products. All of the plastic, rock, and metal that needs to be liquefied. This requires a massive amount of heat energy to accomplish. Often that comes from blast furnaces that are fueled by burning fossil fuel. Electricity alone might not be able to supply that energy, so this is an area where hydrogen might need to be substituted as a molecular combustible energy source in extreme manufacturing like making steel. But that's okay because pure hydrogen has no carbon attached, so burning hydrogen has no negative effect on the environment. By converting this industry, we can reduce fossil fuel consumption by 17%, and it will require $0.8 trillion of investment to get there. The fifth area of work is to sustainably fuel planes and boats, specifically trans-ocean container ships. If we eliminate fossil fuels, we also eliminate tanker ships, but we still need to move products across the ocean. The cost to benefit equation for this industry is more difficult. We're looking at a total reduction of 5% in fossil fuel use with a cost of $0.8 trillion. So this will likely be the last standing use case for fossil fuels, but Tesla is confident that long-range shipping and commercial flight can be electrified. It just requires a new design and engineering approach, just like with an electric car. You have to design for electrification, incorporate the battery into the structure, and prioritize for aerodynamics and mass efficiency, which Elon believes that the same can be done for large commercial transport. So when you add all of those factors together, you get a world that has 100% moved away from a fossil fuel combustion economy and into a sustainable, renewable, electrified civilization. This master plan is all about how we get there, proving that it can be done. That's the biggest hurdle that we need to overcome right now. We as a society need to believe that this is possible, and then we need to work to make it happen. Because if not this, then what? If we don't transition to sustainable energy as soon as possible, then what happens? Nothing good, I'll say that for sure. Don't forget to give this video a thumbs up today if you liked it. That is so important for getting our content out to more people. If you enjoy the content, then you'd probably also enjoy our weekly newsletter. So sign up with the link down below at theteslaspace.com. A huge thank you to all of our Patreon supporters who are listed on the screen now. You help us make the best content we can, and we really appreciate it. Thanks for watching, and we'll see you in the next one.